Good day, everyone. So I am Myral G. Plaza, and I'll be introducing to you the groundwater modeling as well as some of its types and brief introduction about its history. So before we'll proceed to the groundwater modeling, let us first discuss what is groundwater. So groundwater is the water found underground in the cracks and spaces in soil, sands, and rock. It is stored in and moves slowly through geologic formations of soil, sand, and rocks called aquifers. So from the name itself, groundwater, it is water that is found underground. So um, most most of the groundwater is used to grow our foods or to irrigate crops, and it is also a reliable source for drinking water. So in the United States, mostly 50% of the population relies on groundwater as a source for drinking. So in the Philippines, we also have what we called poso or um, well, in which they drilled a hole underground to access the water that is filled in an aquifer. So it is common in the rural places, though. So most of the households there used um, groundwater as a source of water. So next is we have aquifer. So aquifer is a body of rock and or sediment that holds groundwater. Aquifers are typically made up of gravel, sand, sandstone, or fractured rock like limestone. Water can move through these materials because they have large connected spaces that makes them permeable. So as you can see here in the illustration, so let's assume na kaning mga shapes is mao ni siya ang mga materials like limestone and fractured rock. So as you can see, it have spaces in between. So kana ng mga spaces is dira ma-store or ma-content ang ato ang groundwater, and that is how the aquifer works also because of the spaces, so ma-store ang waters. So next is groundwater supplies are replenished or recharged by rain and snow melt that seeps down into the cracked and surfaces beneath the land surface. So mostly of the groundwater came from rainwater or melted snows. So now that we know the importance now or fundamentals or basics of the groundwater, let us now discuss the groundwater modeling. So groundwater modeling is a scientific technique used to simulate and predict the movement and behavior of groundwater systems. So as I said earlier, no, groundwater is a critical source for meeting human water demands. So, however, groundwater is located in a complex subsurface area, which makes it hard for us to locate and manage as it is often hidden from direct observations. So that is one of the reasons why groundwater modeling was developed. So groundwater modeling has evolved as a powerful tool that integrates mathematical simulations and optimization techniques to address the challenges of groundwater management, especially in response to human-induced stress and environmental changes. So next is we have here the applications of groundwater modeling. So first is the water supply management, optimizing groundwater extraction for sustainable use. So groundwater modeling now is used or can be used to predict how groundwater respond to various movements such as pumping, recharge, and climate variations. So next is the pollution control. So predicting the risk of contaminants and mitigating environmental risk. So it helps us to track the movements of contaminants like pesticides, heavy metals, or waste product in groundwater, not to reduce or to avoid contaminations. So next is the environmental protection, modeling to ensure the protection of groundwater quality. So next is we have here some brief history of groundwater modeling. So groundwater modeling began in the 20th century with simple analytical models evolving into a more complex numerical methods such as understanding and data improved. So groundwater modeling in the 20th century mostly used to represent and predict groundwater flow and contaminant transport. So the introduction of powerful computing in the 1980s and 1990s allowed for advanced models like finite difference and finite element methods. So finite difference and finite elements methods are methods that which can simulate underground flow and transport uh, transport process more accurately. So today, groundwater modeling is vital for environmental engineering and water resource management with GIS integration, enhancing its effectiveness. So GIS stands for Geographic Information System. So they now further enhances these models by providing spatial data that improve decision making and resource management. So next, as we have three types of models, so predictive model, interpretive model, and generic model. So predictive model used to make predictions based on hypothetical future scenarios. So these models allows us to forecast the impacts of different management strategies. Next is the interpretive model. It is used to gain a better understanding of an aquifer. So these models helps us to understand the underlying process driving groundwater flow and contamination. So the last or the third one is the generic model. So based on a simple classical case rather than a real system, it is mostly used for academic purposes. So generic is used to establish management guidelines or assess the sustainability of specific regions for groundwater development. So next is groundwater model typically involves hydraulic properties, flow dynamics, contaminant transport, and hydrological data. So hydraulic properties characterizing how water flows through porous media such as soil or rock. So, the hydraulic properties know these are the features of soils and rocks that control how easily water can flow through them, such as the porosity or the permeability. Next is the flow dynamics. So simulating the movement of water under different boundary conditions, including recharge, discharge, and pumping. So this refers to how water moves through an underground system, such as how they enters, exits, or can be extracted. So the third one is the contaminant transport, so modeling how pollutants move with groundwater and interact with the aquifer material. So this is a process of how pollutants travel with underground water, including how they spread and interact with the surrounding soil and or rock. So the last one is the hydrological data. So using physical and empirical data such as geological structure, porosity, permeability, and water level movements to build a realistic simulation. So this is an information about the physical properties of the land, such as type of soil, rock, and water levels used to create realistic models of groundwater behaviors. So groundwater modeling plays a critical role in both understanding and managing aquifers in real-world scenarios, ranging from predicting drought impacts, helping mitigate the effect of contaminant or over-extraction. So, in conclusion, no, groundwater modeling is vital for understanding and managing underground water systems. So, that would be all for my report. So this is just a brief introduction about the groundwater modeling. So later on, you can check out the other report of my group mates as they will discuss um groundwater modeling further. You know, most specifically the hydrological cycle, modeling protocol, model design, and groundwater flow models. So that would be all for my report, and thank you. Bye.